carbon number on this. Review double bonds in terms of covalency. Okay, so for example, we can go through exactly how that occurs, why we end up with one that becomes an alkene. Starting compound will always fit the rule. Starting compound will always fit the rule for an alkane. The first product will also follow this rule. The second product follows the alkene rule. Cool. And a question. C16 is an alkane, which can be used as a starting chemical in cracking. One of the products in the compound is an alkane with 10. Right, okay, so you just do a 10 alkane and then a 6 sized one of those. Nice. Simple stuff, huh? Simple stuff. Various methods can be used for cracking. Okay, you can have catalytic cracking and steam cracking. Okay, cool. The structure of hexane passed over a hot catalyst becomes hot, and then you get it like that. Right, whatever. Reasons for cracking. Yeah, alright. This stuff is so obvious. I just need like a nice little thing to show supply and demand. There's more of the larger hydrocarbons that can be sold and less of the smaller hydrocarbons. What? Alright, let's just do a small point in supply and demand of fractions of the refined slash unrefined products, whatever. I'll just go through that quickly. It's not particularly difficult concept to understand. Alkanes and alkanes. Series of hydrocarbons. Saturated, unsaturated. Oh, let's put it up here. Oh, we did. Alkenes will react with brome in water and turn it from orange brown. As a result, more reactive alkenes can take part in reactions that alkanes cannot. For example, ethene molecules can react together to form polyethene, a polymer. Alkenes, due to the presence of the double bond, they are more reactive, able to take part in reactions that the alkanes cannot. Formation of polyethenes, ethanes even. No, ethenes.